Okay, let's look at the first example. The first example is asking us to determine the x value for any holes or vertical asymptotes in the function. So example 1a, we're going to look and see if any of the parentheses can be divided out or cancel out. And I notice that x plus 3 happens in the numerator and it also happens in the denominator. So I know that since I don't have any x plus 3 left in the denominator, the x plus 3 will give me a hole in my graph. So set it equal to 0, subtract 3 from both sides, I get x equals -3. So I'm going to make a note that I will have a hole in the graph at x equals -3. Since I'm not able to cancel out the x minus 5, I know that that will give me a vertical asymptote at x equals +5. Now, to get the y value of the hole, I know that the x value is -3. Look at what you have left over. So I only have x minus 2 left at the top, and I have a x minus 5 left on the bottom. To find the y value of the hole, replace your x's with -3, or whatever the x value of the hole is. So in this case, I'm going to plug in -3 minus 2 over -3 minus 5. -3 minus 2 will give me -5, and -3 minus 5 will give me -8. Remember, a negative divided by a negative will give me a positive. So the y value of the whole for this function will be 5/8. And then I'm just going to put it together as an order pair. -3, 5/8. Keep in mind that it will be important to find the y value when you're looking for the limits as your x's approach the hole from the left and from the right. Let's look at B. B is the same set of instructions. We are looking for any holes and any vertical asymptotes. So for this one, I'm just going to expand it to make it a little bit easier to understand. X plus 1 times x minus 2 times x minus 2 over x minus 2 times x plus 1 times x plus 1. So I can cancel out an x plus 1 from the top and 1 from the bottom, and then x plus 2 from the top, x plus 2 from the bottom. So I'd look at x plus 1, it did get canceled out, but I'm left with one of them in the bottom. So I'm going to say that I have a vertical asymptote at x equals -1. Again, if it cannot be canceled out, I know for sure it's a vertical asymptote. Since the x minus 2 did get canceled out completely, I know that that will give me a hole in my graph. And then when I set it equal to 0, that will give me x equals to 2. So now I'm going to take what I have, what did not get canceled out, which in this case is x minus 2 over x plus 1, and replace with the x's with the x value of the whole, which in this case is 2. So 2 minus 2 over 2 plus 1. So it will be 0/3, which simplifies to 0. So I know that the whole will happen at 2, 0. Okay, hopefully that makes sense. Let's look at C. So for this one, it is not factored out. I do have to factor it out using the greatest common factor. So what is the greatest common factor between x cubed and 4x? It's x. So I'm going to pull an x to the front, and then I'm going to leave x squared plus 4 on the inside. In order for you to have a whole or a vertical asymptote, the parentheses have to be equal to 0. So that does happen on the first one, but it doesn't happen on the second one. There is nothing that I can plug in into this parentheses to make it 0. So I know I only have one discontinuity or one undefined value. Since I'm not able to cancel it out, I know it's going to be a vertical asymptote at x equals 0. Because when I replace this x value with 0, the whole denominator will be 0, making my function undefined. Again, I don't have any holes on the graph, so I'm going to put hole and A, not applicable, or none. Okay, now that we know how to find holes and vertical asymptotes, we can start looking at limits. For example number 2, it says write a left and a right limit statement as x approaches 2 for each of the following functions. So for example number 2, I'm going to be looking at 2 and decide if at x equals 2 I have a vertical asymptote or if I have a hole. Here, there is no way that I can cancel the x minus 2, so I'm going to make a note that I have a vertical asymptote at x equals positive 2. So that tells me that my limits are going to be infinities. And then I'm going to use some information from the sign chart from before to figure out if my limit is positive infinity or negative infinity. So start by creating a sign chart. The only number that you need is the vertical asymptote, which is 2. After that, we're going to plug in some numbers close to the asymptote that will help us figure out if it's increasing with that bound or decreasing with that bound. So in this case, I'm going to pick a number super close to 2 on the left side of it. So in this case, I'm going to pick 1.99. And then I'm going to plug it into here and figure out if I get a positive or a negative. So 1.99 minus 1 will give me a positive. And then 1.99 plus 3 will also give me a positive. In the denominator, I'm doing 1.99 minus 2, which will give me a negative. And then when I simplify that, that will simplify to a negative. So on the left side, I know that my y values will continue to decrease with that bound because I got a negative as I came closer and closer from the left side. For the right side, I'm going to do the same thing and plug in 2.1 into my parentheses and figure out if I get a positive or a negative. In this case, 2.1 minus 1 will give me a positive. 2.1 plus 3 will give me a positive, and then 2.1 minus 2 will also give me a positive. So I know that they're always, that since all three of them are positive, then I know that I'm increasing with that bound. Now I'm ready to write my limit statements. I know that the limit as x approaches 2 from the left of f of x is going to be equal to negative infinity because of this negative that came from my sign chart. The limit as x approaches 2 from the right for f of x is going to be equal to positive infinity since I have a positive on the right side of the vertical asymptote. Okay, looking at b. Again, we're talking about 2. What's going on at 2? I know that these two cancel out, so I know I have a hole at x equals positive 2. If you remember, I have to find the y value of the hole because the y value of the hole will be the limit from the left and from the right. To find that, again, I'm going to take these two, x plus 4 over x minus 3, and then replace my x's with the x value of the hole, which happens to be 2. So 2 plus 4 over 2 minus 3. 2 plus 4 is 6. 2 minus 3 is negative 1. So that simplifies to negative 6. So I know that the limit as x approaches 2 from the left of g of x is equal to negative 6. And I know that the limit as x approaches 2 from the right for g of x is equal to negative 6. Okay, next example for c. I'm going to erase this real quickly. So I'm going to rewrite it and expand it to make it a little bit easier. So I have a x minus 4 times x minus 2 over x minus 2 times x minus 2 times x minus 1. Again, I only care about what's going on at 2. Do I have a vertical asymptote or do I have a hole? I noticed that x minus 2 did get canceled out, but I'm still left with one of them in the denominator, meaning I have a vertical asymptote at x equals 2. So I'm going to do the same as before. I'm going to create my sign chart and put 2. And then I'm going to plug in, you can always pick the same numbers if you want, 0.9 and 2.1 for these two, since you are looking for the limit from the left for 2 and the limit from the right. So I'm going to do the same thing as before. 1.9 minus 4 will give me a negative. And then for the bottom one, 1.9 minus 2 will also give me a negative. And then 1.9 minus 1 will also give me a negative. So on the denominator, a negative times a negative will give me a positive. giving me a negative here. And then for the other one, I'm plugging in 2.1. 2.1 minus 4 will give me a negative over 2.1 minus 2, which will give me a positive, and then 2.1 minus 1, which will also give me a positive. So in this case, I have two positives in the bottom and a negative in the numerator. So I am going to get another negative on here. So when I write my limit as x approaches 2 from the left for h of x, since I got a negative here, I know that my limit is negative infinity. And when I do my limit as x approaches 2 from the right for h of x, is also going to be negative infinity. We talked about this last time. This is kind of like a multiplicity. Since it has a multiplicity of 2 or it happened twice, I know that the sign on the left of 2 and the sign on the right of 2 will be the same. So in this case, since the left was negative, the right also has to be negative, and that's always going to happen. Okay, so now let's look at example 3. It's asking us to write an equation of a rational function with the following limit properties. For a, it wants a function where the limit as x approaches 3 from the left of f of x is equal to 5, and the limit as x approaches 3 from the right of f of x is equal to 5. Since I have numbers and the limit from the left and the limit from the right are equal to each other, I know that I have a hole at x equals 3. For the second part, it's asking for a function that has a limit as x approaches 1 from the left of f of x equal to negative infinity, and the limit as x approaches 1 from the right of f of x is equal to positive infinity. Since these two are infinities, I know I must have a vertical asymptote at x equals 1. After that, I notice that the one on the left and the one on the right are in that order. So remember your parent functions y equals 1 over x. That looks like this. So when I simplify after I take out the whole, it has to simplify to 1 over 1 single x, or x to the 1. Let's look at the linear pairs that will give me a whole at x equals 3. So remember, it has to be the opposite. So x minus 3 has to happen in both the numerator and the denominator. And then for the vertical asymptote, it needs to be only on the denominator. So since the vertical asymptote is at x equals 1, I need to have a x minus 1 as part of my function. After that, don't forget that when I plug in x equals 3 into my function, I have to get 5 as my answer, since that's the y value of the whole. So what I'm going to do is I'm going to put a k to be whatever, to be a variable that will help me get that 5 that I want. After that, I'm only left with k over x minus 1, and then I'm going to replace my x value with the whole, with the x value of the whole, which is 3. So I'm going to plug it in right here and then say that that's equal to the 5. After that, I get k over 2 equals 5, multiply both sides by 2, and I get k equals 10. After that, I'm just going to put it all together to find my final answer, which is going to be 10 times x minus 3 over x minus 3 times x minus 1. And then that should be my final answer for the function that I want. And then you can say it's equal to f of x or g of x or whatever you want to call it. Okay, looking at the second example, I'm going to do some notes similar to what I did on the first one. So I know that the limit from the left as x approaches negative 2 is 4, and the limit as x approaches negative 2 from the right is also equal to 4. So again, I'm going to make a note that I have a whole at x equals negative 2. And then I notice that I have infinities here, so I know I have a vertical asymptote at x equals negative 1. This one is going to be different than the other one because they're both approaching positive infinity. So for this one, you have to remember 1 over x squared, which is going to look something like that. Notice how both of the arrows are increasing without bound as you approach x equals 0, which in that case is where the vertical asymptote happens. So when I do this one, I have to remember that as I write my equation. So for the whole, since it happens at -2, I need to have an x plus 2 over an x plus 2. And then for the other one, I need to have a x plus 1, and then it has to be squared because of that. When I simplify, I have to have a x plus 1 squared. Don't forget, I need a variable k right here, and then this will cancel out. So when I simplify this, I'm left with k over x plus 1 quantity squared, and then I have to replace my x with the value, x value of the whole, which is -2. So I'm just going to do that here by taking this out and replacing that with a -2. After that, I'm going to set that equal to my y value of the whole, which is 4. And then I'm just going to solve and figure out what the answer is once I find the k. So in this case, this is going to be k over -1 plus 1, which is -1. And then I'm going to square it and say it's equal to 4. So k over 1 is equal to 4, or just k equals 4. After that, I'm going to put it together and say 4 times x plus 2 over x plus 2 times x plus 1 quantity squared equal to g of x. Hopefully that makes sense. I know this is kind of a lot to remember, but just remember the parent functions, and then that should help you with knowing if it's going to be a squared or just a single linear factor. Example number 4 is asking us to sketch a picture of a rational function that has the following properties. So for A, they want a function that has a whole at x equals 1. So as long as your x value is 1, you can put it wherever you want. After that, they're saying that as x approaches -4 from the left, f of x increases without bound. So I'm going to make a note that it should look something like that as you get closer and closer to x equals 4. And then as x approaches 4 from the right, it decreases without bound. So I'm going to make a note that it's going to look something like that. After that, it does have to go through this point, and then I know that 4 is going to be an asymptote. So 1, 2, 3, 4. So I'm going to draw my asymptote here. And I know that I have to increase without bound on this side, and then I have to decrease without bound from this side. So then I can just finish the rest of my graph and make it look like a rational function. So that will be an example. Again, answers will vary depending on how you draw your graph. Looking at B, they want a function g of x with two wholes, one at x equals -2 and one at x equals 3. So I'm going to go ahead and draw that on here. Put two random wholes, one at x equals -2 and one at x equals 3. After that, as x approaches -1 from the left, it's going to decrease without bound. So -1 from the left side is going to look like that. And then from the right, as it approaches -1 from the right, it's also going to decrease without bound. So I'm going to go to -1, and I'm going to put my asymptote there. And then again, I know that both of these will go down as I approach it from both sides. So this would be an example of what the graph would look like. Thank you for watching this video. Hopefully you learned something new today. Don't forget to like and subscribe, and see you next time. Have a great day.